August 23, 2023, a day when India's Chandrayaan-3 spacecraft made history by becoming the first to touch down on the lunar South Pole, a place we can't normally see from Earth. What makes this lunar hideaway so fascinating to scientists? Well, it turns out it's hiding something precious – lunar ice. This place is believed to be more abundant with this ice than what we found up north. And it's not hard to see why scientists are so buzzed up about it. It's a frozen water source, and it could become our key to building a permanent lunar home, or even fueling missions all the way to Mars. Scientists knew about this ice for over 2 decades, since the NASA spacecraft accidentally stumbled upon it during one of the missions. Then in 2018, NASA triumphantly declared that they're 100% sure about it. They said that the south pole of the moon is abundant with water. Now, picture this. Future lunar settlers could tap into this water supply. It could help us sustain life in the barren lunar landscape. Plus, by cleverly splitting the water into oxygen and hydrogen, we could receive both air and rocket fuel. All this will make moon missions more feasible and self-sustaining. It's also a great glimpse into the past. This ice, maybe as old as the moon itself, could unlock the moon's and Earth's deep mysteries. But it turns out that water isn't rare in space at all. There might be lots of planets out there where life could thrive. We know this because we started finding water vapor around stars, and this water is remarkably similar to the water in our own solar system. This discovery suggests that the water on Earth originally came from space. Water forms around stars in the cloud of extremely hot vapor. Then it turns into ice and sticks to tiny dust particles. These particles stick together over time and become bigger objects, like comets, planets, and other things. Some of these become comets and planets in our own solar system. And this is how water is being spread across the universe, and it may be how it got to our planet and the moon too. Scientists think that the lunar ice might have journeyed here eons ago. Maybe it hitched a ride on water-rich asteroids that smacked into the moon's surface. All this has big implications for us. The southern pole is an ideal canvas for humanity to establish a real moon base. Imagine brick domes connected by secret underground tunnels. They'll be bustling with people busily operating computers. Some others will be cruising the lunar landscape in their jeeps or on their way to mine precious resources. We have some pretty cool ideas on how to build this. First, you probably imagine hauling hefty and water-draining shelters all the way from Earth. But maybe there's a more effective way. Think about our history as a civilization. Every time we ventured to a new place, we surveyed the surroundings for available resources and used them to survive and thrive. This is how we spread across our own planet. So why shouldn't we spread across the moon the same way? Now, you might wonder what resources the moon might offer. We know about the ice, and it can be turned into water. But we can clearly see that our planet lacks lush greenery and edible food. Well, it might not be obvious, but the moon does have something to offer – mineral resources and sunlight. Unlike Earth, where the sun rises and sets, the lunar poles offer quite a beautiful sight. The sun gracefully orbits the horizon the entire day, which means it can provide an almost uninterrupted source of power. Imagine living in a world bathed in perpetual sunlight. I'm sure the solar panels will love it. Me? Not so much. Still, we could use not only the sun's light, but also its heat. Honestly, we should just use everything. If we're left with spare metal while producing oxygen, find a purpose for that metal too. We need to treat the environment responsibly, not only on Earth, but on the moon as well. Which is why scientists are learning how to turn the moon's most abundant resources, regolith, into sturdy bricks. They've been quite inventive in figuring out how to create moon bricks. Scientists want to use the sun's heat to melt lunar dust, layer by layer, essentially creating a 3D printer for moon dust. Engineers have also cooked up bricks using solar ovens and zapped lunar soil with microwaves. They become quite adept at it. So yeah, Perhaps we're going to establish a little brick factory on the moon and build regolith houses. It's like Minecraft in real life. As soon as you find some cool new material, you gotta build a tiny house with it. If successful, these bricks could be used to construct entire buildings, potentially covering inflatable modules or giving new life to abandoned landers. So, will astronauts need to become skilled bricklayers? Well, they won't do everything themselves. We'd have to create a small automated system involving robots working collaboratively. Humans will, of course, oversee the construction site. Despite all this automation, scientists believe that living on the moon is going to be, well, call it cozy. The designs may involve stacked living quarters or multi-purpose areas. However, there would be some challenges too. On the moon, things get extreme. Imagine scorching temperatures that can go up to 212 degrees Fahrenheit during the day, and at night, they plunge down to a chilly minus 290 degrees. And it's not just the weather. The moon gets relentlessly exposed to solar radiation, cosmic rays, and micrometeorite impacts. All these things gradually wear down anything on its surface. Another big challenge is the lunar dust. On the moon, there's no air to breathe, and the dust there can cause problems. And this one isn't only regular dust. It's super clingy and can even make astronauts sneeze and have watery eyes, as if they're having a lunar hay fever. It can also damage equipment and spacesuits. It's not something you want to mess with. Scientists have found that the dust is made when meteors hit the moon, creating tiny particles and sharp glass shards. It's toxic, and its tiny particles can float around in low lunar gravity, making it hard to breathe. Unlike on Earth, the moon doesn't have wind or rain to clean it away. So now they're studying it to find out how to prevent this annoying problem from ruining their entire mission. There's more to this lunar haven than meets the eye. Scientists also want to delve into the mysteries of low-frequency electromagnetic waves there. These waves are whispers from the far reaches of the universe. These elusive signals have remained hidden from us for ages. We only caught some cacophony of radio and other background noise, but that's it. On the moon's dark side, however, we can finally record and study them. Studying these waves will help scientists to unlock the secrets of the universe's origins. It's not just about the Earth or the moon. We're talking about peering back to the very beginnings of our world. Our new lunar lab might help us to forever reshape our understanding of the cosmos. So, NASA has some big plans on the moon now. Their Artemis mission completed a successful return to Earth in December 2022 after nearly a month in space. It ventured far beyond the moon. This mission proved the capabilities of some of our recent technological developments that will help us explore Mars. The goal of Artemis is to establish a lasting presence on the moon. They want to create a gateway, like a space station in orbit around the satellite, to help with the landings. Artemis 2 is set to carry astronauts to lunar orbit in 2024, and during Artemis 3, which should take place in the mid-2020s, 2 astronauts will touch down near the moon's south pole. It's quite possible that the lunar base will be built within the next couple of decades. So, stay tuned.
Our moon exploration project started out in 1969. Sure, there have been some problems along the way, but astronomers are certain we'll get back up there pretty soon and with better knowledge and technology. However, there's an 800-year-old trick that might become way more useful than fancy GPS tech and powerful rockets. It's called the Fibonacci sphere. Some scientists at a Hungarian university stumbled upon this idea while studying the moon. They believe it might be useful to better understand how the moon spins and how it's a bit squished while it goes around Earth. You might believe that our planet and its satellite are these perfect little spheres floating in space. Well, that's not true. They are in fact like slightly deflated soccer balls because of all the gravity, rotating movements, and tides. The GPS technology we use here on Earth is already adapted to these less than perfect ball proportions. Remember, our planet is a bit flattened at its poles. If we're going to make a map system for the Moon, we need to do the same for its shape, called a solenoid, or what scientists call the Moon's version of our Earth's shape. Since the Moon is less compressed than our planet, scientists have been taking a shortcut until now. They've been looking at our satellite as a simple ball shape. However, with all these new projects coming up in the following decades and even some exciting trips we might end up having on the Moon, we need to be more precise. Scientists now believe we should get the real data and start drawing an accurate picture of the Moon. Here's where the Fibonacci sphere comes in handy. It's a clever solution that's been used by mathematicians to spread points out evenly on a ball. Scientists recently used it to map around 100,000 spots on the Moon using data previously collected by NASA. And what they found was crucial for our understanding of the Moon's shape. For instance, we now know that our satellite's poles are about 0.3 miles closer to the center compared to the Moon's equator. Sure, it might seem like a tiny detail, but if we adjust our GPS software accordingly before we land on the Moon again, it might save us from getting lost up there. This level of math hasn't been done since the 60s for the Moon, but we already know it works wonders here at home, so it only makes scientists better prepared for future missions. This isn't the first time people have used Fibonacci's findings to come up with clever solutions. We've also seen it put to work in finance, agriculture, and in computer science. Let's see where it all came from. Legend has it that the Italian mathematician Fibonacci wasn't really that interested in mathematical sequences at first, but rather in rabbits? So, he came up with this interesting puzzle. What happens if you place a pair of rabbits in a certain space for a year? He also set some theoretical rules. For starters, all those bunnies come in boy-girl pairs, and they can start reproducing after just a month. Each month, each bunny pair adds one more pair of bunny offspring. The last rule was that all bunnies would be invincible for the year. Doing the math, he got this series of numbers. 1, 1, 2, 3, 5, 8, and so on. If you look at this series again, you'll notice that every number is the sum of the two before it. The first two, that's your starting bunny pair. Next, you'll see the number 2, which is the first pair and their first offspring pair. Word caught on about this interesting sequence, and math lovers began studying it more closely. They started seeing this pattern very often in nature, like in how leaves grow on a plant or how seeds arrange on sunflowers. There's even a little experiment you can do to check it out. Start by grabbing some paper and a pen. Try drawing the Fibonacci spiral. Start with a tiny circle, then go bigger and bigger using those Fibonacci numbers. The first circle should just be a tiny dot on the paper, or the equivalent of 0. Next circle, 1 unit. Another circle, still 1 unit. Keep it going and you'll see that the circles form this spiral pattern. Even as it continues to grow, it keeps its shape. You might have also stumbled upon the Fibonacci spiral as a symbol of hypnosis. In all fairness, there's little evidence you can confuse someone by making them stare into a spiral for a while. But its effects on our focus and our optic nerves can't be ignored. After you've stared at a spinning spiral, you might see how objects get smaller or bigger depending on the direction of the swirl. It's easy to understand why some experience this sensation as hypnotizing. This interesting series of numbers appears in our day-to-day lives, even if we don't notice it. It can also be used in more practical instances, like converting miles to kilometers. Let's look at the series 1, 2, 3, 5, 8, 13. Pick any two numbers side by side. Say 13 and 21. Do the calculations and you'll notice that 13 miles is about 21 kilometers. Same with 34 and 55. Music and math might not seem like they're connected, but if you had asked the great Mozart, he probably wouldn't have agreed. It seems he was very passionate about numbers from early on in his career. He loved finding cool number patterns in music, like some sort of hidden messages. His own sister even remembered him doodling math all the time, even on the sides of his music sheets. Some scholars believe he might have even played around with the Fibonacci numbers, if that's really the case, then he might have used the ration to balance out parts of his tunes. What about other types of art? Well, it's also said that Leonardo da Vinci used the golden ratio in his masterpieces, like the Vitruvian Man and the Mona Lisa. Also, when it comes to great pieces of architecture, the Parthenon might have used this pattern too. Anytime you see buildings with columns spaced just right, you can be certain that's where the builders drew inspiration from. The Great Pyramid of Giza is another great example. There's no official record to prove it, but the pyramid's shape is so close to the golden ratio that it's kind of obvious. You'll also see this pattern appearing naturally in our environment. Go out in our garden and check to see if you have any pine cones lying around. See those scales? They're set up in a pattern according to the Fibonacci sphere. Even the bones in our body seem to be growing based on the same proportions. We've got one torso, one head, and one heart. Then there's stuff that comes in pairs. Our arms, legs, eyes, and ears, for instance. For the number 3, think about the composition of our limbs and the 3 main sections in our hand. The wrist part, the middle palm part, and our fingers, which are also split into 3, by the way. Oh, speaking of fingers, their bone lengths have this ratio too. This design helps our fingers move smoothly, especially when grabbing objects. The Fibonacci sequence can be seen in the way ocean waves curve, and how rivers split and flow too. Weather patterns can also follow this rule. Some whirlpools and hurricanes form and spread out in the same way the Fibonacci spiral does. Zoom out, and you'll see that spirals aren't just found here on Earth. They're also everywhere in space, and it isn't random. Most galaxies, including our Milky Way, are spirals. Think of it like this. Generally, stars in a young galaxy don't all appear at once. Some are faster when developing, others take their time. This makes gravity pull in different ways, making the young galaxy spin like a disk. As it spins, different levels of gravity stretch it into getting these spiral arms. On the flip side, if all the stars in a young galaxy appear at the same time, gravity just smushes it all into an egg shape, or what the astronomers call elliptical.
It all started with a minor change on our planet. At first, people noticed the moon had become brighter and a little bigger, but nobody paid attention to this. The moon affected tides all over the world. The water flooded the beaches, but it wasn't a tragedy. A lot of fish came close to the shores. People found giant squid, anglerfish, and other creatures next to the coast, although they usually live in the dark depths. New, stranger things happen every day. Birds no longer fly to the south in winter. They gather in huge groups, flying around cities with no purpose. The moon used to help them navigate in nature, so they can't figure out which way to fly anymore. In the boundless waters of the world's oceans, ship captains notice that compasses are now unstable. The arrow is pointing in different directions since the Earth's magnetic poles have changed. People realize the moon has started to approach Earth for an unknown reason. The moon's gravity affects the gravity of our planet. This entails changes in the climate, the behavior of all living beings, and the magnetic field. Now, it rains in the driest places and gets hot in the coldest lands. It's knocking down ecosystems all over the planet. People living near forests hear wolves howling all the time. The moon drives these animals mad. The Earth's natural satellite is growing in size and lights up the night much brighter. Nothing critical has happened yet. People don't panic because they don't want to believe the end is coming. But then, one day, the moon reaches a critical point. You're walking down the street listening to music, and at that moment, someone pushes you. Okay, maybe that guy is late for work. You keep walking, and a girl coming by hits your shoulder. "I'm sorry," she says, and goes away. You've noticed the fear in her eyes. You look ahead and see people running towards you. You take off your headphones and hear screams and sirens. People leave their cars and run away. Hundreds of seagulls are flying in the sky. You hear a strange noise among all the sounds of chaos. It seems to be water. How is this possible? You're in the city center, a few miles from the shore. But there's no time to think. You notice a huge wave flooding the streets and heading straight to you. You run into a building and go up to the 10th floor. From here, you're watching the water filling the city. The strong stream blows all cars, one-story buildings, and trees off the road. You notice a shark and other fish in the water. People are hiding in houses and on the roofs. The whole city is quickly plunging into a catastrophe. The TV is working in the building where you're hiding. You learn that floods are occurring all over the world. Massive tsunamis cover coastal cities. In some places, waves reach the height of a 30-story building. Many towns have been washed off the face of the earth. The moon is too close to Earth, and massive floods are just the beginning. The moon flies around Earth and helps to keep our home on its axis. The moon provides climate stability and helps living organisms develop. But now, this balance is broken. The moon is approaching and changing our planet's gravity. Earth can tilt slightly to the side and provoke massive floods around the world. Imagine that you're holding a round glass of water. Tilt it a little. See how the liquid moves from one side to another? The same thing is happening now with the oceans. But the moon is not just approaching us. It's flying around the planet and getting closer with each circle. It causes natural disasters in different locations on Earth all the time. Now the ocean floods one side, and a few hours later, another. So you see all the water going back from the streets to the shore. The oceans may return to the city again by the end of the day. Wait a minute. It seems the end of the day has already come. You notice that the sky has become dark. It's weird, because it's only 3 p.m. The moon changes Earth's rotation speed and makes the day go faster. The moon covers almost the entire sky and brightly illuminates our planet. You see huge lunar craters. It's so close that you can still see it even when the sun shines. In some places, the passing moon obscures the sun. The water is leaving the streets and everyone goes outside. At this moment, an earthquake begins. The road is cracking and the houses are collapsing. There are landslides on the street. Tectonic plates are shifting all over the planet. Imagine two magnetic balls that are approaching each other. So, one ball is the moon, and the second one is Earth's core. What do you think will happen to what's above the core? That's hundreds of thousands of miles of the Earth's crust. And now, it's all moving. Destructive cracks are emerging all over the world. The planet's highest mountains break down and turn into a pile of stones. The seabed cracks and releases magma from the underground depths. Volcanoes wake up and erupt magma. Clouds of volcanic ash cover the sky from the sun and the glowing moon. But the scariest thing is still ahead. A collision is inevitable. The moon flies around the planet like a ball in a round glass with a hole in the center. This force drives clouds all over the planet. Now there's a thunderstorm, but in 5 minutes, it will be snowing. Then the night comes, and it starts raining. Water droplets consist of mud and volcanic ash. It's difficult for people to breathe without gas masks. Atmospheric pressure is constantly changing. Some people experience severe migraines, and some have sore joints. But there's no time to think about your health. Humanity needs to figure out how to save itself from the collision. A new gravitational order will come when the moon crashes into Earth. Continents will change their shape. They will combine into one giant piece of land or split into 100 smaller ones. The energy of the collision can burn all the oxygen in the atmosphere and make the planet unsuitable for life. Hiding underground also makes no sense because of deep earthquakes. People decide to spend their last hours with loved ones and their families. The moon is getting closer. It's now at the same distance as the International Space Station. The moon covers the sky. Many cities are in the shadows because of the waves. Tsunamis, several miles in height, crash down on the ground. Millions of tons of magma collide with the ocean. Billions of gallons of water just evaporate. Moisture rises into the air, mixes with ash, and floods the land in the form of giant cumulus clouds. You've accepted the complete destruction of the planet. But something strange happens to the moon at this moment. You notice giant cracks appear on it. The moon slowly begins to divide into two parts. Both halves crumble into hundreds of large pieces. It's just falling apart. the Earth doesn't have a natural satellite anymore. It's just a pile of giant space rocks. But why is this happening? There's a space around our planet called the Roche limit. In this place, the gravity of Earth is stronger than that of the Moon. This means that the forces holding the Moon together are weaker than those that tear it apart. People are cheering. The Roche limit has saved the planet. The Moon won't hit us. It breaks up into millions of fragments and forms a circle around our globe. Now, Earth looks like Saturn. A belt of moonstones surrounds us. Huge chunks destroy everything in their path, all the space debris. The satellites are no longer working. Humanity loses its means of communication and navigation. People will have to use paper maps again. The Moon held our planet's orbit at a certain angle before these events. Now the axis is tilted differently. One hemisphere becomes closer to the Sun, and the other plunges into shadow. The North Pole and the Arctic may turn into hot deserts, and the equator of the planet may be covered with ice. Winter and summer can last for years. The Moon's remnants fly around Earth, but some of them fall on our planet. Lunar meteor showers destroy cities and create giant craters. All these events lead to the massive destruction of life on Earth. It will take hundreds of thousands of years to adapt to the new world.
Now look at this fancy granite kitchen countertop. This one can also be available on the Moon. I mean, there's no production whatsoever as of now, but there's enough raw materials for the kitchen of your dreams. And by the way, granite on the Moon can even prove this dark horse had plenty of water at some point. So it all started when scientists found this weird blob of heat on the far side of the Moon. It's all because of a massive chunk of granite that's buried underground. Apparently, granite is pretty rare outside of Earth, so this is a big deal. According to the researchers, there's this old volcano on the Moon that hasn't erupted in like 3.5 billion years. But it turns out it's still giving off some serious radiation. The scientists used a fancy new method with microwaves to measure the temperature below the Moon's surface. They found this area that's about 31 miles across, where it's like 18 degrees warmer than the rest of the place. And it's right under a spot that collapsed and is full of silicon. It's not as thriving as Silicon Valley back on Earth, it's just a volcanic crater, but without all the lava spewing out. The scientists even compared it to those granite rocks you see in Yosemite, like El Capitan and Half Dome. You know, those giant rocks that look super majestic? Well, apparently, they're made of the same stuff. Researchers claim that granite is super common on Earth, but not anywhere else in our solar system. So, this could change everything we know about other rocky planets. Right, now we know there's granite on the Moon, but why is that important to us? So, you know how granite forms on Earth? It's all thanks to water and plate tectonics teaming up to create these huge blobs of melted rock beneath the surface. But guess what? The Moon doesn't have any of that action going on, which makes granite super rare up there. But this discovery could give us some clues about what the Moon was like back in the day when it had volcanic activity. Without water, making granite becomes a real challenge. But somehow, someway, they found granite on the Moon. No water, no plate tectonics, but still, we got granite. So what does that mean? Did the Moon have water in this one spot? Or was it just ridiculously hot? I guess we'll need to give a tad more time for the scientists to figure it out. The water on the Moon is an issue, though. Duh. As of now, the Moon is bigger than the Sahara Desert, but somehow 100 times drier. Astronomers have been debating for ages whether there's any water on this celestial neighbor of ours. But in 2020, NASA's SOFIA mission finally confirmed that there is indeed water on the sunlit part of the lunar surface. Turns out those grains of lunar dust have little molecules of H2O hanging out on them. Back in 1645, when people first started gazing at the Moon, they were fascinated by these dark spots all over its surface. Dutch astronomer Michael van Lengren even made a map and called these spots Maria, which means seas in Latin. Sorry, Michael, they're just actually plains of basalt from ancient volcanic eruptions, but we still use the term Maria today. In 1892, an American astronomer named William Pickering discovered that the moon has practically no atmosphere. No clouds, no atmosphere, no chance for water to stick around. So, scientists started thinking that the moon was as dry as a desert. But then, in the 1960s, a theoretical physicist named Kenneth Watson came along with an idea. He suggested that water ice could actually exist in the shadowy craters of the moon that never see sunlight. These areas are called permanently shadowed regions. It was a mind-blowing concept at the time. The Apollo missions from 1969 to 1972 finally gave us the chance to look for water on the moon up close and personal. But when the astronauts brought back soil samples, there was no sign of water. So everyone went back to thinking the moon was bone dry. However, in 1994, NASA's Clementine mission suggested that there might be ice in these shadowed craters after all. And in 1998, the Lunar Prospector mission found evidence of hydrogen concentrations in the permanently shadowed areas. This was a strong indication of water ice at the lunar poles. The images weren't super clear, but it was still an exciting discovery. And finally, in 2008, scientists decided to take another look at those Apollo samples. They revisited the old data and found some hints that there might be water after all. It was like finding buried treasure in your own backyard. As you can see, the moon is a pretty promising destination. It even has enough stuff to produce your food supplements – calcium, magnesium, you name it. Just kidding, it's not the best idea to munch on them to boost your diet. But there are a bunch of other applications they can be used for. Calcium is like the fourth most popular element hanging out in the lunar highlands. But here's the cool part. Pure calcium metal is actually super flexible and can conduct electricity like a boss when there's no oxygen around. Who knew, right? Anorthite is a rare gem here on Earth, but up on the moon, it's partly central for calcium. It can even help make those groovy silicon-based solar cells. To make them, you need some lunar silicon, iron, titanium oxide, and of course, our buddy calcium and aluminum. It's like a recipe for solar success up there in space. The moon even has precious metals like gold. In 2009, NASA was on a lunar mission and they found some gold in the lunar soil. They had a spacecraft right behind the rocket, equipped with a fancy spectrometer. Its job was to study all the debris that got released when the rocket crashed. And they found all sorts of chemicals, like carbon monoxide, carbon dioxide, ammonia, sodium, hydrogen, and even a little bit of mercury, gold, and silver. Hey, vampires beware. Now I know it's been quite a while since then, like 14 years to be exact, but measuring how much gold is actually there has been a real challenge. You see, it's hiding deep beneath the lunar regolith, making it tricky to get an accurate count. Yeah, metals are fun and lunar water may have existed, but what about food? Good news, everyone! Scientists are saying that plants can actually grow on the moon, but don't expect a luscious orchard. It'll be more like a moderate garden with just a couple of beds. Here's the scoop. A while back, those awesome Apollo astronauts collected samples of lunar surface material called regolith and brought them back to Earth. Fast forward 50 years, and NASA decided to use 3 of those samples to try growing plants for the very first time. They used dirt from under the lunar rover bumper to grow these plants. The team added water and seeds to the samples, giving each plant a gram of regolith. Then they placed them in a clean room and added nutrient solutions every day. And they succeeded. During that challenge, the brilliant minds dealt with small plants like mustard greens in the nutrient-poor lunar soil. Yeah, we'll have to export olive oil from Earth to dress it. So, plants can indeed grow in the moon's soil. However, they won't be as strong and healthy as the ones grown on good old Earth soil, or even the ones in the control group grown in a lunar simulant made of volcanic ash. But hey, it's just a start. We're still to find out if our dear moon is hiding more treasures. There's something happening inside the moon, something that nobody expected. Not a dramatic shift you'd see on the outside, but deep down, where things seem frozen in time, scientists have uncovered a hidden layer of what you could only call moon goo. Remember those school lessons about the crust, mantle, and core? Much like the Earth, The moon is made up of layers, a crust, mantle, and core. However, the moon's core is much smaller compared to ours. Earth's core is huge. It makes up about a third of our entire planet's mass. The moon's core makes up only about 1 to 2% of its mass, and its diameter is about 1/5 the diameter of the moon itself. It's surrounded by a hard, rocky mantle. But it turns out that between these two layers, that mysterious goo layer, and it's way more important than you might think. The layer is soft and partially molten, ebbing and flowing like the tides in our oceans. It rises and falls, stretching and shifting as if it were alive. Its movement isn't chaotic, but subtle and regular. We always knew that the moon influences our seas and oceans, causing tides with its gravity. But it turns out that we influence it back. The goo ocean reacts to the gravitational dance between Earth and the Sun. Also, the molten layer could be made of ilmenite, a very intriguing material. Ilmenite is rich in titanium, a strong and lightweight metal that we really love over here on Earth. Titanium is used in everything from airplane parts and spacecraft to medical devices, even in everyday items like bikes and laptops, all because it's incredibly strong and very resistant to corrosion and heat. So, if the moon might have a molten layer rich in ilmenite, that would be awesome. Astronomers are already planning for lunar bases, and if we had a material to build structures, spacecraft, or even tools for astronauts right there, that would be a game changer. Otherwise, we'd need to transport materials from Earth, which is extremely costly. This is our first tangible sign that the moon is not just a cold, boring rock. Instead, it's dynamic, living, and breathing, with moving forces beneath the surface. NASA used new special tools to discover this: the Gravity Recovery and Interior Laboratory and the Lunar Reconnaissance Orbiter. These are both space missions designed to study the moon, but they don't just look at the surface like a telescope. Instead, they help measure things we can't see with our eyes, like the moon's gravity and how it changes over time. Grail sent 2 small spacecraft around the moon named Ebb and Flow. Clever. The idea was for these spacecraft to fly close to each other and measure tiny differences in the moon's gravity as they go. It's like they were feeling the moon's invisible pull in different places. If the moon's gravity was stronger in one spot, the spacecraft moved closer together, and if it was weaker, they moved farther apart. This helps scientists understand what's going on inside the moon, even if they can't actually go there. And the spacecraft intentionally crashed into the moon in December 2012 to end the mission. The Lunar Reconnaissance Orbiter is a bit different. It takes super detailed pictures of the moon and collects other important information about its surface. By combining the information from both Grail and LRO, we were able to find this goo layer. But this discovery actually challenges everything we thought we knew about lunar geology. How did this molten layer get there? How long has it existed? And perhaps more fascinating, how it stayed warm for millions of years? That's some million-dollar questions. The moon's core generates heat just like ours. But it's not as easy as saying, oh, the core's heat probably keeps it warm and molten. Well, first, the moon's core is much smaller and less active than Earth's, meaning it produces significantly less heat. Plus, the moon is much cooler than Earth in general. With temperature dropping to minus 200 degrees Fahrenheit on the surface, how could this inner layer still stay in this flowing state? That's still a mystery. In any case, this goo could actually explain a lot of stuff about the moon. For example, astronomers were exploring moonquakes and how they happen. Now they think that it might be this semi-molten layer shifting and moving beneath the surface. Now, beyond the moon itself, it also tells us more about other celestial bodies. If the moon, something we considered basically a huge static rock, has such a dramatic life, what about other planets, moons, or asteroids? Could they also hide similar hidden movements beneath their surfaces? We can even understand our own planet better, learn more about how tides and similar stuff works. There are so many great discoveries we've been making on the moon. Recently, we found some awesome stuff beneath the surface, massive caves hidden for millions of years. For over 50 years, scientists have suspected that the moon's surface is full of underground tunnels and caves. These are known as lava tubes because they were formed by lava. Duh! Millions of years ago, the moon was pretty unstable. It underwent some volcanic activity, causing eruptions. When a volcano erupts, lava can flow across the surface. As the outer layer of the lava cools and hardens, it forms a solid roof of dark material. It's actually what these famous dark spots on the moon are. These are dark, hardened remains of ancient lava. But the hot, molten lava continues to flow through the center. Once the eruption ends and the lava drains away, what's left behind is an empty hollow tunnel, hence a lava tube. On Earth, we have lava tubes in places like Hawaii or Iceland, where volcanic activity has created similar underground tunnels. The same thing happened on the Moon billions of years ago, although they're much crazier compared to ours. In fact, lunar lava tubes are now thought to be some of the largest and longest in the entire solar system. One such cave was discovered beneath the famous Mare Tranquillitatis, the place where Apollo 11 first landed, and it's at least 340 feet deep. Now, all these lava systems have remained hidden just beneath the surface, untouched for millions of years. Only now, they finally managed to prove their existence. Scientists from the University of Trento in Italy found them using special radar technology and advanced computer methods. These techniques let you see underground by sending radar waves. The waves bounce back and give clues about what's hidden underneath. By analyzing the way these waves reflected back, the researchers could detect the shape and size of the hidden caves. Now, the best thing about this discovery is that we could build all our bases there. These caves protect from radiation, harsh winds, and meteoroids. NASA even found evidence that some of these caves stay at a steady 63 degrees Fahrenheit. That's some crazy coziness for the moon. And on top of that, there could even be some water there. So humans could take shelter inside these natural tunnels and build entire colonies on the moon. And I know what you're thinking. Could unexpected lunar monsters hide deep in those caves? Well, sure. There's a huge potential for exploring these caves and finding some awesome stuff. But even if we manage to find a miracle, like small life or microbial organisms, there's a 99% chance that there won't be actual animals or monsters. It would just be impossible for them to develop in such conditions. But it would make a great horror movie. Researchers want to send robots or drones to explore the tunnels first, and then see if they're safe enough for humans. And it's not just the US getting in on the action. China is also investigating the possibility of using these moon caves as a future base, showing that the race to explore and settle the moon is heating up.
Under your feet, the moon is pulsing. You feel danger with every pore of your body. The lifeless satellite, or so you thought, stays still for a second before knocking you down to the ground with a powerful tremor. Is it a moonquake? For years, scientists believed the moon was completely inactive, but the newest evidence seems to suggest that this idea is totally wrong. Researchers from the University of Maryland have recently discovered 266 mysterious ridges on the far side of the moon. And these ridges likely point to recent geological activity. So, are we really talking moonquakes? Well, kind of. The ridges are located in volcanic regions that formed 3.2 to 3.6 billion years ago, but they appear much younger than expected. Typically found in clusters of 10 to 40, they're often located in areas where the moon's surface is structurally weaker. Now, when astronomers speak about recent, don't take their words literally. They don't mean last year or even decade. Most models scientists created suggested that the moon's geological activity ended 2.5 to 3 billion years ago. But the new information hints at the possibility that these formations have been active within the last billion years. Some of the smaller ridges seem to have formed as recently as 200 million years ago, and that is considered relatively young on the moon's timescale. It means that the moon may still be experiencing geological changes today. These discoveries kinda challenge our understanding of the moon's history and evolution. But how did scientists come to these conclusions anyway? Researchers from the University of Maryland and the Smithsonian Institution used crater counting to estimate the age of lunar ridges. It works like this. Surfaces with fewer craters are younger, and the more craters some region has, the older it is. Plus, the analysis showed that some ridges cut through already existing craters, meaning they likely formed around 160 million years ago. In geological terms, this is very recent, suggesting that these ridge-forming processes may still be happening. Another cool thing is that the ridges on both the near and far sides of the Moon are similar, which means they may have formed through the same geological processes, having been shaped by the same forces. These forces might include the Moon's gradual shrinking, thermal contraction, and shifts in its orbit. We'll talk about it a bit later. Another argument supporting the idea of a still active Moon is decades-old data from the Apollo missions. They had already detected shallow moonquakes with the Apollo Lunar Seismic Experiment, recording 28 quakes ranging from magnitude 1.5 to 5. Researchers believe that these ridges may be linked to similar seismic activity. Now, about that bizarre shrinking of our natural satellite. Scientists believe the Moon formed about 4.5 billion years ago when a Mars-sized object collided with early Earth. This catastrophic impact likely sent bunches of superheated material into space. Eventually, they came together and formed the Moon. In its early years, the Moon was just a molten world, shaking from intense volcanic and seismic activity. So, the Moon used to be a molten mess floating through space. But when did it actually solidify? Scientists have finally figured it out, 4.43 billion years ago. This was a huge turning point, not just for the Moon, but for Earth too. After all, the giant impact that formed the Moon might have also been the final blow that made Earth stable enough to support life. In any case, billions of years passed. The Moon gradually cooled and contracted. And now look at this modern-day rocky sphere illuminating our nights. But the Moon isn't completely rigid yet. It still keeps cooling. And this slow cooling of its core might be one possible reason for the Moon's continued activity. As it cools, the Moon's interior contracts, which leads to cracks and shifts in the crust. One of the clearest signs of this contraction is found in the lunar maria. See these large, dark patches on the Moon? Those are called maria, areas formed when lava filled ancient asteroid impact craters and then solidified. Then, over time, the cooling and contracting crust created these wrinkle ridges. Another factor of the ongoing geological activity could be the Moon's gravitational interactions with Earth. Such non-stop powerful interactions likely create surface stress and trigger tectonic movements. It's all good and exciting, but can this activity on the Moon actually affect humans? In a sense, it can. The Moon has long been seen as a stable place for future bases and resource extraction. But the discovery of this ongoing geological activity is pretty worrying. If the surface is still shifting, future settlements, infrastructure, and mining operations could face serious risks. That's why, at the moment, we need seismometers and ground-penetrating radars to better understand these movements. It will allow us to assess potential dangers before any long-term missions begin. By the way, there's another potential problem future lunar missions might have to deal with, and it's moon dust, aka regolith. Apollo astronauts quickly learned that this jagged, sticky dust gets everywhere and can damage suits, equipment, and even health. A new study from Texas A&M engineers found another problem. When rockets land or take off, they kick up regolith, which can become a collision hazard, especially with many spacecraft bringing crews and cargo to the Moon. Lunar regolith comes in all sizes, from tiny dust particles to large rocks. The main ingredient in moon dust is fine silicate materials, about 70 microns in size, like a human hair. They formed over billions of years as meteors and asteroids smashed into the Moon's surface, grinding much of it into powder. Unlike Earth, the Moon has almost no atmosphere. It's incredibly thin, so there's no wind or water to smooth out the dust. On top of that, Constant exposure to solar wind has given the regolith an electrostatic charge, making it stick to anything it touches. Apollo astronauts quickly found this out the hard way. Moon dust clung to their suits, got trapped inside their landers, and stuck to everything. Worse, it became a health hazard, causing eye irritation and breathing problems inside their spacecraft. But at the moment, it seems like a problem for future us. A much more important issue is finding water to support future missions, and China is going to deal with it. It's getting ready for a big mission to look for hidden ice on the moon. As part of the Chang'e 7 mission in 2026, a flying robot will explore deep craters at the moon's south pole, where ice might be trapped. If they manage to confirm it, this could be a game changer for future lunar missions. Astronauts will have a water source and even fuel for space travel. The mission is a key step in China's plan to land astronauts on the moon within 5 years. While signs of water have been found before, like in soil samples from Chang'e 5's probe and observations by NASA and Indian spacecraft, scientists believe that deep ice deposits are the real key to supporting future missions. The south pole of the moon has some incredibly deep craters, and experts think ice could be hiding inside them. The flying robot will try to explore one or more of these craters after landing. If it does find the ice, it could make long-term moon missions much cheaper and more practical, helping astronauts live and work on the moon. Some scientists also think that this discovery could offer us some clues about extraterrestrial life. In any case, whether we find water on the moon and learn to deal with that pesky dust or not, the recent discovery of those young lunar ridges is a game changer. If the moon is still geologically active, it means we don't know as much about our closest neighbor as we thought. What else could the moon be hiding? Are we really prepared for the idea that this lifeless satellite might actually be more dynamic than we imagined? Future missions, which might not be as safe as we once believed, will probably show.
The space crew had been getting ready for the launch for over 3 years. The preparations for landing on the strange planet included gathering and studying rock samples in the Grand Canyon, exploring ancient volcano formations in the Nevada National Security Site, and looking into gas and lava vents, lava lakes, and pit craters in various locations in Hawaii. To be able to resist microgravity conditions, they learned how to walk obliquely by being strapped and suspended sideways and trying to move along walls. They had to test their limits through intensive diet and sleep regimens to make sure they'd be safe in outer space. It took them 3 days, 3 hours, and 49 minutes to reach the surface of this new world in a place called the Sea of Tranquility. They could have gone for the Ocean of Storms or the Central Bay, but they chose this place to land because it had good visibility and it was relatively smooth and easily reachable with as little propellant as possible. One of the first things they noticed when they got there was that, well, the place kind of smelled. This may sound like the beginning of a science fiction novel, but it's actually the true story about how the Apollo 11 mission landed on the moon on July 20th, 1969. Since then, the moon has had 12 human visitors to this day. We think of it as our neighboring space buddy, but there's still much we don't know about this mysterious satellite. And that should come as no surprise, since the moon is actually always showing us the same face. That is because the Earth and its only permanent natural satellite are in synchronous rotation, which makes us think it's always permanently still. The truth is, it's not in a fixed position, and it is actually moving further and further away from the Earth each year by 1.5 inches. Believe it or not, the Earth and the Moon, although being 238,855 miles apart, deeply influence each other. While the Moon is partially responsible for the tides of the seas and oceans on our planet's surface, our Earth is actually to blame for movement on the Moon. They're called moonquakes, and they last way longer than earthquakes, some of them up to half an hour. It may look perfectly round to us on a warm summer's night, but the Moon is actually oval. The lemon-like shape is caused by the Earth's gravitational pull. Our moon features more than footprints when it comes to traces of humans. In 1969, American astronauts left many objects on the surface of our satellite, such as 2 golf balls, a drawing by famous artist Andy Warhol, and a message from Queen Elizabeth II herself. One of the last people to walk on the moon to this day, an astronaut named Eugene Cernan, scribbled his daughter's initials on the moon's surface in 1972. Since it appears there's no wind or any other type of weather change there, the letters TDC could remain there permanently. It's actually possible to be allergic to the moon. Harrison Jack Schmitt, an astronaut from the Apollo 17 mission, spent some time in a valley in the Sea of Serenity, then climbed back into the crew's lunar module, but had some moon dust on him. Just as he removed his spacesuit, he got red eyes, sneezing fits, and other allergic reactions that lasted 2 hours. Since it's so close to us, we've established that the moon has a time zone of its own. We call it the Lunar Standard Time, but it doesn't correspond to time on Earth. To get an equivalent, the explanation is a bit more complex, but in simple terms, a year on the moon is split up into 12 days, each one about as long as a month on Earth. Each one of these days got its name after a different astronaut who has walked on the moon. The start date of this calendar coincides with the moment Neil Armstrong walked on the moon. So, the Lunar Year 1, Day 1, began on July 21st, 1969 at 2:56:15 Universal Time. Since the moon has a very thin atmosphere, it has some pretty crazy temperatures, both hot and cold. They can go up to 200 degrees Fahrenheit. Over by the moon's poles, however, the temperature is always at around minus 400 degrees Fahrenheit. Humans have tried to trace the connection between our natural satellite and the Earth for as long as we can remember, coming up with words to explain why the moon's existence influences us so. In the Middle Ages, scientists and philosophers thought that during a full moon, some people were more likely to experience different health conditions. Because they saw this inexplicable connection to the full moon, people with these symptoms were named lunatics, or at times, literally, moonsick. People are not the only creatures living on Earth that are affected by moon cycles. Dog owners are 28% more likely to take their pet to vet emergency rooms during the full moon. You may think that's the reason why wolves have this preference for howling at a full moon, more so in popular culture. But scientists haven't been able to find any connection between wolf behavior and the lunar cycles, so it might as well just be a myth. The largest known crater in our solar system is also found on our moon and is called the South Pole Aitken. This giant formation is located on the far side of the moon and measures 1,550 miles in diameter. One of the many things we've yet to fully understand about our satellite is the unusual flashes of light that can sometimes be seen on its surface. Scientists have named these outbursts transient lunar phenomena, or TLP in short, and they have been seen all over the world for centuries. One of the first instances of TLP dates back to 1178, when monks from Canterbury claimed to have seen a flaming torch on the surface of the moon after the sun had set. TLP does not simply mean light flashes. Reports also have detailed other unusual events, such as gas-like mists, reddish, green, blue, or violet colorations, or even the darkening of certain locations on the moon. Is something strange happening with our moon? Is it the beginning, or did we just start noticing it with the newer space study equipment we have nowadays? There are a lot of different theories that scientists have developed trying to piece together what can be causing these events. The unusual flashes on the moon can be caused by anything from meteoric impacts to electrostatic activity. It's difficult to pinpoint the explanation for each event, since most of these episodes are recalled either by a single observer on Earth or from a single location. The fact that there is noticeable seismic activity on the moon can also explain why we can sometimes see unusual flashes of light on the surface of our satellite. When the moon's surface moves, it can cause different light-reflecting gases to erupt, which can explain luminous developments. Some scientists have even suggested that residual geologic activity may also be the cause. This is all the more shocking, given that we've always looked at the moon as a lifeless world. Did you ever notice that our moon can change its color? There are actually many scientific explanations for that. The moon appears to be a brown-tinted gray when you look upon it from outside of the Earth's atmosphere. When gazed upon from the Earth's surface, the moon appears to change color depending on various phenomena. The moon seen near the horizon will most likely be yellow or red tinted. The rarer blue-colored moon indicates that you're looking at our satellite through an atmosphere carrying larger dust particles. The moon can even appear purple at times, but what causes this specific hue is still up for debate. The fact that we don't know exactly if or how much water there is on the moon's surface is not the main reason why we aren't already building houses up there. It seems that radiation actually has a lot more to do with it. Recent studies have shown that the moon's surface has a radiation rate 5 to 10 times higher than that you experience on a transatlantic passenger flight. That also means it's 200 times higher than the rate on the Earth's surface. In future lunar explorations, like the Artemis project for example, scientists need to take this into consideration, not to expose the astronauts. Named after Artemis, Apollo's sister, this program aims not only to place astronauts on the lunar surface in the future, but also to build some sort of an establishment there to study the moon in safe conditions. While the project started in 2017, the first planned mission is set for launch in summer 2022, with an estimated duration of 25 days. The space object, with no crew on board, is planned to reach lunar orbit and safely return with sufficient data for the next 4-person mission scheduled for May 2024. Artemis 3, 4, and 5 are expected to be launched in 2025, 2026, and 2027 respectively, each with a planned duration of approximately 30 days.
It's dark outside, almost 2 a.m. You go outside and look at the sky, and here it is, bright, full moon. You might think you know a lot about Earth's natural satellite, but let me ask you this: how did it form? The answer is nobody knows. But of course, there are theories. The most popular one, called the giant impact theory, claims that the moon formed during a collision between Earth and another planet. This planet must have been smaller than ours, the size of Mars, and the collision itself probably happened around 4.5 billion years ago. Another theory, called the capture theory, claims that the moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. But here is one catch. Our planet and the moon have remarkable isotopic and chemical similarities. So, they must have a linked history, which means the moon couldn't have been created elsewhere. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet. That's how the moon appeared in the sky. But again, there's one problem. In this case, the proportion and type of minerals on the moon would have to be the same as on Earth. But there are slight differences. The moon is richer in materials that form very fast at high temperatures. There's one more theory, and it's probably the least exciting. It claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. Duh! But these days, a more urgent question keeps astronomers busy. Is the moon really Earth's satellite? Or are these two twin planets? The moon is big compared to our planet, about 1/4 of Earth's size. That's why some experts refer to our planetary system as a double planet. But how correct is that? If we want to figure it out, we need to give the definition to the word planet. According to the International Astronomical Union, a planet is a space body that orbits the Sun, is massive enough to have a nearly round shape thanks to its gravity, and has cleared the region around its orbit. Now, what about a satellite? It's an object in space that orbits around a larger celestial body. If we take the system Earth, the Moon, its center of gravity, called a barycenter, is inside the Earth. That's why at the moment we can't say that we live in a twin planet system. According to this definition, the Moon is the satellite of our planet. Now, let's get back to the past, like 3 or 4 billion years ago. Even though the Moon wasn't a planet, it most likely had a full-fledged atmosphere. It formed at times when powerful volcanic eruptions were rocking our satellite. Gases spread all over the Moon's surface, and it happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurtling high into the air, falling to the ground and creating lava flows. That's how the basalt basins appeared on the surface of the moon. At one point, scientists got their hands on samples brought from the moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggests the moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days our satellite is around 240,000 miles away. That's why the moon looked much, much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view. These days, the atmosphere of the moon is almost non-existent, and that's why the satellite can't protect itself from meteorites. The surface of the moon is dotted with craters. For comparison, there are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the moon, the number is so much greater, several million, and around 5,000 of them are more than 12 miles across. And since the moon is less seismically active than Earth, these craters and other ancient formations stay in perfect condition for centuries. When you look at the moon, it's the brightest object in the night sky. But in reality, its surface is dark because the reflectance of our natural satellite is just a bit higher than that of asphalt. You might know that the moon's gravitational pull causes tides on our planet, making the oceans bulge out on both the side closest to the moon and the one farthest from the satellite. But that's not all. The moon also slows down Earth's rotation. This phenomenon is known as tidal braking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. If one day the moon floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the moon's gravity, Earth's tilt would start changing wildly, from no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Even though the moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. One theory suggests that they may be happening because the moon is shrinking as its insides are cooling. Scientists say that the moon has become around 150 feet skinnier than it used to be several hundred million years ago. To help you understand it, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the moon. It's shrinking and it's wrinkling. But unlike the grape, the moon doesn't have flexible skin. Its surface is hard and brittle, so as the moon gets smaller, the crust cracks and breaks, and its sections get pushed over neighboring parts. Want to know another cool thing about the moon? A recent study claims that it has a tail, and every month it wraps around our planet like a scarf. This slender tail is made up of millions of atoms of sodium, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. And the spiciest fact for you, 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it was no larger than an average car, it was still a big deal. Out of more than 1 million asteroids astronomers know about, it was only the second one to orbit our planet, called 2020 CD3. It was our temporary mini-moon. It didn't stay with Earth for long, though. The asteroid followed a random orbit and slowly drifted away. Temporarily captured objects such as 2020 CD3 are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. So Mars has 2 moons, Phobos and Deimos. And apart from the bizarre shape, there's nothing remarkable about them, except for one thing. Not so long ago, scientists discovered a strange phenomenon on the surface of Phobos, and they still can't find any explanation for it. What is this phenomenon, and what does it tell us about the history of our solar system? Let's find out. American astronomer Asaph Hall discovered Phobos and Deimos back in 1877. Did you know that all the planets in our solar system are named after Greek and Roman deities? For example, Mars or Ares is the famous deity of war. That's why the satellites of this red planet were named after the sons of Ares, Phobos and Deimos. These beautiful names actually have creepy meanings: fear and horror. In 1971, NASA's Mariner 9 telescope took the first pictures. That's how we found out that these guys weren't at all like our moon. They had this weird shape, a strange and unstable orbit. Moreover, there are no other moons in the solar system that move as close to their parent planet as these two. Well, they are its suns after all. But even though they are very close to Mars, if you were standing on the surface of the red planet, you would hardly be able to see them. That's because the curvature of Mars hides Phobos and Deimos from view. Even if you were somewhere on the equator, Phobos would look like an ordinary asteroid to you, and Deimos would look like a star. All because these satellites are basically crumbs compared to our moon. They're the smallest and least bright moons in the entire solar system, which is ironic considering their mighty names. Anyway, it seems that everything should be pretty clear with these 2 satellites. But nope, there's a problem. You see, scientists reconstruct the history of space based on the traces found on different space objects. Dents, scratches, cracks, all these things can tell us what happened billions of years ago. For a long time, scientists were sure that, just like their Greek prototypes, Phobos and Deimos were twins. But then, NASA's Viking orbiter took new photos of the satellites, and that's when they discovered a significant difference between the 2. The entire surface of Phobos was covered with huge grooves. Those were a series of long, deep pits stretching from one end of Phobos to the other. You may say, what's the big deal? All space objects have this kind of stuff on them. And yeah, there are other satellites with similar grooves and scratches, but none of them has as many as Phobos. It's completely covered in grooves, and they're huge, up to 12 miles long and 660 feet wide. And that's not all. Some of these grooves intersect with others. This means that Phobos has experienced not one, but many traumatic events. But what exactly happened to it? Actually, scientists are still not completely sure. However, they have a few ideas, and these theories can tell us not only about the past of Phobos, but also predict its future. Theory 1. Asteroid impact. Well, the first suspect is quite obvious. There's a large, almost 6-mile wide crater on Phobos. It's called Angeline Stickney. It was named after the wife of Asaph Hall, the scientist who discovered the satellites. Adorable. So that's what the first theory sounds like. Once upon a time, an astronomical body crashed into Phobos. The impact was so strong that it left a large crater. And the effect of the collision left a bunch of grooves everywhere on Phobos. It sounds logical at first. However, scientists have noticed a flaw in this theory. They learned that these grooves actually formed not inside the crater, but next to it. So it wasn't a collision that created them. Besides, what about those grooves that intersect with the others? Or is it just a big cosmic coincidence? Well, the search for truth continued. Theory 2. It's all because of space debris. Yes, there's a difference between these two theories. In this case, the grooves aren't a direct consequence of the collision. Rather, it goes something like this. Something crashed into Phobos. This impact caused a bunch of rocks to be thrown into space. Some of them were lost in the universe forever, but others were small enough to be pulled back to Phobos. Passing next to the moon at a steep angle, they would crash into it, jumping away, and so on. And since the gravity of Phobos is very weak, perhaps they couldn't stick to it. In other words, these rocks were continuously pulled toward and pushed off of the satellite for many, many years. This theory explains the intersecting grooves. It's because the rocks were constantly falling into those places. It sounds quite logical, but there's another problem. We don't see any boulders on Mars or on the surface of its moons. But all this debris was supposed to get trapped by gravity and remain somewhere in the planet's orbit. This, or simply become part of Phobos. In other words, if this were true, we'd find evidence of this theory under layers of dust. But that didn't happen, so this explanation didn't satisfy astronomers either. Therefore, they continued to look for the culprit. Maybe the grooves have nothing to do with Stickney Crater at all. Maybe the real culprit is something else, something even more powerful. Could it be Mars itself? Theory 3. Mars is a twist villain. The previous theories imply that Phobos and Deimos were originally pieces of Mars. Like once upon a time they broke away from it and became satellites, just like our moon. But what if that wasn't the case? Observations made by NASA's Mars Global Surveyor show that Phobos and Deimos are made up of elements which are mainly found in meteorites and asteroids. So, what if Phobos and Deimos are asteroids? There's an asteroid belt between Mars and Jupiter. Given the size, shape, and composition of Phobos and Deimos, scientists have suggested that once upon a time they belonged to this belt. However, one day they flew out of it, and then gravity pulled them to Mars. This phenomenon is called asteroid capture. It's very strange though. Yeah, the asteroid capture isn't uncommon, but these two have been flying next to Mars for what, billions of years? It's weird that their orbits have remained the same. In addition, the atmosphere of Mars is very rarefied, and because of this, it could hardly capture any asteroids. In theory, they should have separated from Mars at the first opportunity. However, this didn't happen. It means that somehow they got stuck, and Mars immediately began to destroy them. Yep, an unexpected twist. In this version, Mars turns out to be a villain. By studying the past, we've found some evidence of future crimes. The mysterious grooves of Phobos could be caused by tidal forces between Mars and Phobos. The Moon and Earth also exchange these, slightly distorting each other. But since Phobos is much closer to Mars, the impact of gravitational forces is much stronger. In other words, the gravity of Mars is gradually destroying Phobos. Every 100 years, the satellite gets 0.7 inches closer to Mars. It also shrinks as much as 6.5 feet, becoming even more fragile and weaker. The smaller it gets, the more the tidal forces impact it, creating strange grooves and scratches on Phobos. Yep, somewhere in 30 to 50 million years, Phobos will either collide with Mars or disintegrate and turn into a bunch of small rocks. And then Mars will also have rings, like Saturn and Neptune. That's why Phobos is called the doomed Martian moon. Anyway, these are all only theories, but the dramatic backstory of Phobos gives us an idea of how dynamic extraterrestrial objects can be. The more we learn about them, the more we discover about the secrets of the origin of not only Mars, but also other objects in our solar system. If one day we really colonize Mars, studying its moons can help us a lot. Let's hope that the upcoming MMX mission will reveal some of the most exciting secrets Mars's moons are hiding.
Have you ever seen the other side of the moon? I caught you. Of course not. But maybe you've seen it in photos. In that case, have you ever wondered why the two sides look so different? Well, let me tell you. We can't see the other side of the moon. People believe this is because the moon doesn't rotate around its axis. But this is not true. The moon does rotate. It just does it at the same rate as its orbital motion. This is a particular case of tidal locking called synchronous rotation. The first time we ever saw a far side was only in 1959, all thanks to the Soviet Luna missions and later the US Apollo program. Now, when Luna 3 and other spacecraft transmitted the first far-side images, they revealed a far more cratered hemisphere that looked more like Mercury or Jupiter's moon Callisto. It looked completely different from what we were used to, and that's when we learned how meh the other side is. No, seriously, just look at it. The near side can boast its thinner and smoother crust. These beautiful dark splotches are called lunar mare, the last remnants of ancient lava flows. And when I say ancient, I mean it. They're more than 3 billion years old. Meanwhile, the far side crust is thicker and crater-pocked. The lava flows had almost no effect on these impact craters. It's also devoid of any large-scale mare. Low-key looks like dried white cheese. To be honest, don't you agree that the nearby side is much more beautiful? Write your thoughts in the comments. So, only 50 years ago, we learned something about the apparent differences. But then the scientists discovered something weird. Both sides are different, even in the geochemical composition. And not only in this, our side was thinner than the far side by several miles. But where did such significant differences come from on an ordinary floating stone ball? For scientists, this was a mystery. They started coming up with a lot of theories. The melted moon theory was the main one for a while. It said that it was the Earth's fault that our moon looks like this. This happened several billion years ago. The moon was born because of a collision. One day, an object about the size of Mars crashed into the Earth. At that moment, a piece broke off from it, which later became the moon. However, this piece was somewhere 15 times closer to Earth than it is now. Some scientists created pictures of the so-called early moon. Unlike our cute little white ball, the early moon was a strange-looking, boiling scarlet ball. That piece didn't leave us after the separation. It became tidally locked very soon after. The Earth after the collision was still an incandescent nightmare, full of fire and lava. It was boiling at a temperature of 4,500 degrees Fahrenheit. And since the moon has always been turned toward us with one side, this side has melted down a little. This would explain why the moon's surface, the so-called mantle, is thinner on the near side than on the far side. During the boiling of the Earth, certain elements evaporated from it. They then settled on the moon. This would explain the difference in geochemical composition between the two sides. But there was a plot hole in this theory. If that's what happened, then where did rare foreign chemical elements come from, such as unusual isotopes of phosphorus, potassium, or tungsten? The nearby site is full of them, and they couldn't have come from the Earth. There were also other theories. Another one said that initially we had 2 teeny-tiny moons. Later they merged into a big one, hence the difference in their composition. But this theory sounds a bit crazy, and it has a plot hole too. For example, the transition between the two sides is way too soft. If our moon was actually 2 tiny moons, this transition would be more abrupt. So scientists were kind of at a loss on this one. But recently, they finally figured out what really happened to the moon, all thanks to NASA's Grail orbiters. They spent over a year whizzing around the moon, mapping it out, and studying its composition. Using this data, scientists have created around 360 computer simulations. They contain different impacting objects of many sizes traveling at different speeds. Scientists were comparing the results with our current moon. They tried to determine which result was the closest to what we have today. And so, they finally solved this 50-year-old mystery. The answer lies in a collision with a dwarf planet. This collision occurred 4.3 billion years ago. This huge object was slightly larger than Ceres. For those who don't know, Ceres is one of the dwarf planets of our solar system. Its diameter is 580 miles. You could say that one France or one Germany would fit into it. So, this giant object crashed into the Moon, somewhere near the South Pole. This collision was so strong that it changed the image of the Moon forever. It left a trail of 3,500 miles behind. It would take you 14 hours by plane to fly that distance. This crater covered the entire near side of the Moon. It caused damage to the Moon's mantle. It also created a so-called South Pole Aitken Base, or SPA Basin. This is an impact crater and has a diameter of 1,600 miles, which is like adding one UK plus one Germany. It's important, though. The formation of this basin was a defining event in the history of the Moon, and it's the second largest impact crater in the solar system. The collision also caused a powerful hot wave to spread across the Moon. This wave scattered over the remnants of those rare warm minerals scientists found on the nearby side. That's how our beautiful side became home to something called Procellarum creep terrain, or PKT for short. This is basically a compositional anomaly, a concentration of potassium, phosphorus, and other rare elements like thorium. You can say that those minerals are a gift to us from deep space. Anyway, there were many, and I mean many, collisions in the Moon's history. All of them only deepened this already large crater. That's why the mantle on the near side was getting thinner and thinner with the years. Also, our gifted minerals gave off a lot of heat, so the mantle has melted a little bit more and more. Oops, this accidentally caused the Moon's volcanoes to wake up. Volcanic activity has increased on the near side. Intense lava flows filled the old empty craters. Ta-da! And this is how the beautiful lunar mare was born. That's about how it all happened. All this information was found thanks to the researchers from Brown, Purdue, Stanford Universities, and NASA's JPL. The research was published by the Journal of Geophysical Research, Planets, so you can read about it in more detail if you're interested. There are still many things we need to learn about the Moon. The highest priority is the return mission from the South Pole, the Aitken Basin. Samples brought from there will be used to determine the age of the Moon, its history, and the nature of the crust and mantle more accurately. Another critical target is the Moscovians. This is the name of a large lava plain on the far side of the Moon. Studying it will help us better understand the difference between the two sides, as well as tell us how the other side was formed. All this knowledge is significant for understanding the history of the Moon, but it's also handy for space exploration in general. Scientists use the Moon as a reference point to determine the age of other planets and entire worlds in space. The Moon helps us determine the chronology of the life of the whole solar system. So stay tuned for new exciting research and discoveries.
Technological progress does not stand still, and over the past decade, the resolution of images of the lunar surface has improved greatly. Many pits have been discovered on the surface, and some of them are really impressive in size. The largest are hundreds of feet deep. However, technology is not yet advanced enough for us to study the bottom of such pits in detail. That's why a recent discovery is surprising. It turns out that huge pits can extend deep into the rock of the Moon. It's a groundbreaking discovery. Let's figure out why. So look at this giant underground cave. Leonardo Carrere and Lorenzo Bruzone from the University of Trento were thrilled to finally confirm the existence of such structures on the Moon. They analyzed images taken by the mini RF instrument on board the Lunar Reconnaissance Orbiter in 2010. The original images didn't have excellent resolution, so the authors had to do a huge amount of work, using modern data analysis and modeling techniques. But first things first, why does it all matter so much? Well, instead of building homes on the surface of the Moon, we might be able to live inside these natural caves. They could offer protection from dangerous things like harmful space radiation, extreme temperature swings, and even meteorites. According to planetary geologist Wes Patterson from Johns Hopkins, even though we'd still have to bring materials from Earth to make those caves habitable, using them would be a lot easier and cheaper than building bases on the surface. Based on the collected data, the cave is about 150 feet wide and up to 260 feet long, which is just a bit smaller than a football field. It's located in a deep pit called the Mare Tranquillitatis Pit, which likely formed when an ancient lava tube collapsed. Although the moon has no active volcanoes today, billions of years ago, its surface was covered with lava that flowed through valleys, carving out these tubes below the surface. Over time, some of the lava tubes became unstable and collapsed, creating pits like the one in question. NASA's Lunar Reconnaissance Orbiter, LRO, has already found more than 200 of such pits on the moon. It means there could be hundreds of hidden caves waiting to be explored on our satellite. When publishing their findings in Nature Astronomy, the researchers suggested that the caves could offer future astronauts a safe place to live and work, protecting them from the moon's extreme conditions. And extreme they are. One of the biggest challenges of living on the moon is its temperatures. The lunar surface gets extremely hot during the day, reaching about 250 degrees Fahrenheit, and then the temperature drops below minus 200 degrees Fahrenheit at night. But inside the caves, the temperature could stay much more consistent. A separate study done in 2022 used computer simulations to predict that some of those caves could maintain a comfortable temperature of about 63 degrees Fahrenheit. Much easier to manage, right? Unfortunately, getting to the caves won't be easy. The Mare Tranquillitatis cave is over 400 feet below the surface, at the bottom of a steep slope covered in loose debris. It would take some clever engineering to get up and down that slope. The options could be using jetpacks, a lunar elevator, or some other kind of technology. We must find a way to transport astronauts safely. There's also a lot more to discover. Radar technology could help scientists find even more caves and lava tubes on the moon. In the future, a spacecraft with higher resolution radar could even map the insides of the pits that LRO has already found. According to the researchers, this kind of complete survey could help them figure out the best locations for future lunar bases and other explorations. And there's another potential bonus. Those caves could contain water. Scientists have already found frozen water on the moon, under the surface, and in permanently shadowed craters. Tiny amounts are also scattered across the lunar dirt. Water is a critical resource for any moon base, and finding it in the caves could make the idea of living there even more realistic. All in all, this discovery could be a game changer for lunar exploration. Living in natural caves on the moon might be a more practical and safer option than building something on the surface. It could also bring us one step closer to making the moon a place where humans can live and work for the long term.
Soon we might start constructing loads of stuff on the moon. All because India's moon mission has recently detected sulfur near the moon's south pole. This chemical element can come in extremely handy for creating infrastructure on our satellite. It's the first time this chemical element has been discovered on Earth's natural satellite. This sought-after element is mostly found near Earth's volcanoes. Its appearance on the moon speaks volumes about the satellite's volcanic history and its past atmospheric conditions. The mission's rover detected this chemical element less than a week after touching down around 70 degrees from the moon's south pole on the 23rd of August, 2023. This historic landing on the lunar surface made India the fourth country to safely land a mission on the moon. It's also the first spacecraft to touch down so close to the south pole of our satellite. It's an area of strategic importance because it's believed to be home to deposits of water ice. If it turns out to be true, future missions might be able to harvest it and turn this water ice into drinking water or even rocket fuel. For 2 weeks, the lander carried out the data collection, mainly focused on the analysis of the moon's soil and its extremely thin atmosphere. Meanwhile, the solar-powered Pragyan rover started its quest to find frozen water on the moon. As for the lander, it demonstrated another amazing feat on the 3rd of September. The spacecraft fired up its engines and lifted itself for about 16 inches into the air. Then it made a tiny hop to land 12 to 16 inches away from its original position. It's kinda a big deal. Being able to get a lander back off the surface of the moon is essentially for future missions, showing that they can safely return soil samples or even astronauts back home after a lunar mission. In September, the Indian spacecraft was put into sleeping mode. The 14-day-long lunar night was approaching, and the spacecraft wasn't designed to collect scientific data during this period of time. So far, we've learned about a few major findings of the mission. One is related to measuring the temperature of the moon's topsoil at different depths. Intriguingly, the surface of the satellite in that region turned out to be hotter than expected. It was believed that the temperature could be between 68 and 86 degrees Fahrenheit on the surface, but it was around 158 degrees Fahrenheit, way hotter than it should be. The other discovery indicates the presence of several chemical elements, including oxygen. Besides, the data received from the spacecraft confirms the presence of aluminum, calcium, iron, titanium, silicon, and other chemical elements on the lunar surface close to the South Pole. The rover also used special instruments designed to measure quakes and rumbles beneath the lunar surface to detect some seismic activity. It brings us back to the sulfur detected thanks to the rover's spectroscope. Scientists are currently working on figuring out whether this element formed on the surface in a natural way or whether it's the result of volcanic activity or a meteor strike. Another astonishing thing found on the moon is a rock, and it may be the oldest known Earth rock. A 0.7-inch wide chip included in a large rock collection brought to our planet by Apollo astronauts might actually be a 4-billion-year-old fragment of Earth. This finding could help us paint a better picture of the intense pounding early Earth got at the dawn of its life. It could go like this. Soon after the rock formed, an asteroid impact might have blasted it from Earth. At that time, our planet's satellite was 3 times closer to Earth than it is today. The collision was so powerful that this chunk of terrestrial rock found its way to the moon. Later, this fragment got engulfed in a lunar breccia, a motley kind of rock. Eventually, the rock was brought back home to Earth by Apollo 14 astronauts. Even though scientists had found meteorites coming from Mars and the moon before, it was the first time a rock from the moon turned out to be a terrestrial meteorite. They also found out that the rock had formed in a water-rich environment at temperatures and pressures corresponding to those at around 12 miles beneath the surface of our planet. In 2019, China's Chang'e 4 mission made history by landing on the far side of the moon. The mission's rover helped researchers visualize structures hidden deep below the surface of the satellite, revealing billions of years of lunar history. The Yutu-2 rover made this discovery with the help of its lunar-penetrating radar. It imaged deep into the moon's surface and listened to echoes of sound bouncing back off structures hidden from view under the surface of the moon. It turned out those structures were resting at depths of almost 1,000 feet. The research suggests that the first 130 feet under the surface are made up of layers of dust, soil, and rocks. The instruments also discovered a concealed crater that must have formed after a large object slammed into the moon's surface. Long, long ago, ancient lava was likely to be flowing deep underground. Researchers believe that the broken rocks around the formation might be debris produced by the impact. They also found that the volcanic rock layers were thinner the closer they were to the surface. Such a thickness variation of lava flows might mean a decrease in the number and magnitude of eruptions over time. So, lunar volcanic activity gradually dwindled since the moon's formation around 4.5 billion years ago. On the far side of the moon, there is one of the largest and oldest impact craters in our solar system, the South Pole Aitken Basin. Unfortunately, from Earth, you can only see its outer rim, which looks like a huge chain of mountains. It's a ginormous 8-mile deep dent, stretching for more than 1,500 miles in diameter and covering 1/4 of the Moon's surface. Astronomers are sure that this crater appeared when an asteroid collided with the Moon around 4 billion years ago. And now, look at this gigantic chunk of metal the size of 4 states of Connecticut. As for its weight in pounds, it's enough to say that the number contains 18 zeros. This mysterious mass is hidden about 180 miles under the Moon's surface, somewhere in the middle of the South Pole Aitken Basin. It was discovered when GRAIL, which stands for NASA's Gravity Recovery and Interior Laboratory Mission, gathered data about our natural satellite. When examining this information, scientists noticed that in one place on the Moon's surface, there was a weird change in gravity. After researching this phenomenon, they concluded that something mysterious was weighing down the basin floor there. So far, researchers haven't figured out the origin of the bizarre lump, but there are several theories. One of them claims that the finding is a chunk of dense oxide, which appeared when the Moon was just taking its shape. At that time, the satellite was still covered with ancient oceans of magma, and the lump could be formed at the final stages of its cooling. However, most scientists support another theory, according to which the puzzling mass is part of the giant asteroid that once created the South Pole Aitken Basin. Since the thing is metallic, it's probably the iron-nickel core of the asteroid. There might be a labyrinth of lava tubes on the Moon. Not so long ago, astronomers received the results of underground topography and discovered a massive cave under the surface of Earth's satellite. It could be the result of the lunar volcanic activity that happened more than 3 billion years ago. Streams of lava hardened, creating a thick, hard crust on the outside. But inside, it kept flowing, melting the rock and creating tunnels and caves. Numerous small pits in the Moon's surface discovered by NASA seem to be the openings to such lava tubes. If this theory is confirmed, the underground tunnels might serve not only as a convenient location for human-crewed space missions, but also as much-needed water sources for astronauts.
People stop their cars on the highway, get out of them, and lift their heads in wonder. In the cities, everyone takes to the streets. Balconies and rooftops of houses are full of people staring at the Moon in shock. It's red. Some people scream that it's the end of the world. Some seek shelter. Indeed, the usual white moon now looks like it's been doused in red paint. There's no need to be afraid if you see such a thing. On the contrary, enjoy the view, because you have witnessed a rare astronomical phenomenon. This is a total lunar eclipse. Here's the Sun. It's in the center of our solar system. Mercury, Venus, and here's Earth and the Moon. The Earth takes 365 days to orbit around the star. At the same time, the Moon revolves around the Earth and completely orbits our planet in 27 days. The Earth creates a shadow zone, and sometimes the Moon passes through it. The shadow is cone-shaped and gradually narrows. The Moon is 238,000 miles away. That's like 9 lengths of the equator. At this distance, the width of the shadow is about 2.6 times the width of the Moon. When the Moon is in this zone, direct sunlight doesn't reach it. That is, it should have disappeared, but instead, it becomes red. All because the sun's rays pass through the Earth's atmosphere. They scatter, and most of the blue light disappears. But the red and orange rays continue and hit the surface of the Moon. Voila! You see a phenomenon called the blood moon. By the way, this curvature of light occurs at sunsets and dawns. The atmosphere scatters the blue light, and you see a red and orange sky. If you were standing on the surface of the Moon during a total lunar eclipse, planet Earth would be exactly between you and the Sun. So you would be able to observe the solar eclipse. The surface of the Earth would become entirely dark for you. All you'd see would be the Sun's corona illuminating the edges of the planet. The Earth from the surface of the Moon is almost the same size as the Moon from the surface of the Earth. Such a red eclipse of the Moon is rare because several factors must coincide. One of them is that the Moon must be full. Usually, you can see 2 total lunar eclipses a year. In 2038, you'll be able to see 4 such eclipses. And the eclipse itself can last up to 108 minutes. But this is rare, and the last time such a long blood moon was seen was in 2000. Many years ago, people didn't know so many facts about our satellite, and the sight of a red moon frightened them. It was a bad sign and a harbinger of trouble. People who knew the schedule of eclipses could take advantage of it. For example, Christopher Columbus had an astronomical almanac and knew when the next lunar eclipse would occur. He frightened the inhabitants of the Caribbean islands when he predicted the red moon. Once upon a time, the moon used to be a red ball of lava. This was way back in time, 4.5 billion years ago. Now this is our solar system. It's full of dust and asteroids. They're constantly bumping into each other, playing space billiards. This is Earth. It's just beginning to cool off from the constant asteroid and comet impacts. But then, Theia appears on the horizon, a planet the size of Mars. It had a chaotic orbit and was approaching Earth in a spiral. A collision was inevitable, and at one point, one of the biggest crashes in our solar system occurred. Theia struck the Earth at an angle. It ripped out part of the Earth's crust and threw it into space. The Earth, in turn, absorbed part of the planet that rammed it. The debris from the collision circled the Earth for a long time. They were a kind of ring, almost like Saturn's. Debris in orbit collided and piled up around a common center of gravity. And that's how the Earth got the moon. There's a theory that this collision helped give birth to life on our planet. Theia hit the Earth at a perfect angle. If the crash had been head-on, both planets would likely have been destroyed in a massive explosion. If the impact had been tangential, then there wouldn't have been enough debris in Earth's orbit to form the moon. But we got the lucky ticket. The moon stabilized the Earth's rotation. The collision shattered the planet's solid crust and allowed oceans to form. Remember, water is the basis of life. When the cores of Earth and Theia merged, we got a powerful magnetosphere. This protects all living organisms from solar radiation. The moon, along with the sun, controls the tides. Its gravity seems to draw water to it from the Earth's surface. The sun does the same thing. That is, if we imagine the Earth as a ball of water, there would be 2 mountains, one on the moon's side and one on the sun's side. And as the moon moves around the Earth, this mountain of water moves with it. If you were in the open ocean with a tape measure, you would see that the moon is attracting water to itself by about 4 to 6 inches. The moon is gravitationally locked with the Earth. That's why it's always turned to us with one side, like Mercury and the sun. But the moon doesn't stand still. It's gradually moving away from our planet, about 1.5 inches a year. Not quickly, but in about 600 million years, it will have shrunk in our sky so much that we won't be able to see lunar eclipses anymore. Do you see this crater? It's Tycho. It's visible during a full moon because of these bright rays that extend thousands of miles from its epicenter. This is the youngest crater on the moon. Scientists say it appeared there due to a meteorite impact about 109 million years ago. At that time, dinosaurs were roaming the surface of our planet, and they may have seen the impact. It was most likely accompanied by a big explosion and looked like a salute in the night sky. Humanity loves to explore the moon. We've sent a bunch of missions there. A total of 12 people have set foot on the surface of the moon. The gravitational force there is 6 times less than on Earth. So if the average person on our planet weighed about 180 pounds, on the surface of the moon, the scales would only show 30 pounds, like the weight of an average dog. That's why the astronauts moved, jumped, and fell so strangely there. And you would be 6 times stronger on the surface of the moon. Here on Earth, the average person could lift about 130 pounds, but on the moon, you could raise a big motorcycle or a grizzly bear. The surface of the moon is covered with regolith. This is the lunar dust that covers the solid ground. Such dust is good at preserving footprints. Here's the most famous footprint, which gave birth to many crazy theories. Here's the footprint, and here's the shoe that left it. But the shoe is completely flat. This is explained simply. The astronauts wore extra boots for walking on the lunar surface. They have exactly the kind of sole that left these marks. In addition to the footprints, we left many fascinating objects on the moon. Several lunar rovers, a golf ball, flags, and human waste. There's also a lot of broken satellites and rocket parts. All in all, about 413,000 pounds of human-made objects are there. That's the weight of 3 passenger planes, or 31 adult elephants. In the future, we plan to resume missions to the moon. New landers will explore the surface of our satellite to find natural resources there. It's also a great place to test new rovers. We're even going to build something like the International Space Station in the moon's orbit, the Lunar Orbital Platform Gateway. It'll be a convenient platform for exploring our satellite and launching spacecraft into distant space. If you start from here, the spacecraft won't need to spend almost all its fuel to overcome the force of Earth's gravity. So, such a station would save fuel and money. Scientists hope that we'll be able to mine water from the moon's surface. It's been proven that there's ice there, mostly at the bottom of craters where the sunlight doesn't reach. Perhaps we'll send a rover there that can drill down a few feet into the surface, searching for water. Humanity already has the technology to build a full-fledged colony there. It would take up to 3 days to get there. We just need to get enough solar panels and building materials to the moon. There's no atmosphere on the moon, so potential lunar inhabitants would be defenseless against solar radiation. We would have to build houses underground to provide protection. Modern 3D printers will help make construction easy and fast. However, food and water supplies can only be maintained by constant supplies from Earth. The same goes for oxygen. Each rocket launch costs millions of dollars, so for now, colonization of the moon is in question. The moon could also become an object for space tourism. Imagine a spaceship launches from Earth, 3 days on the road, and you're orbiting the moon. The lunar module undocks, and you land on the surface. You ride the rover, explore the craters, then return to the lander. The engines start, the lander returns you to orbit. You dock with the ship and return to Earth. Sounds like some pretty great plans for a week's vacation.
Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve. What caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth, in its early stages, and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water, but that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one skywatcher studied the Moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the Moon would just disappear right away. They believed the Moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the Moon in special areas called permanently shadowed regions. These are spots on the Moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the Moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the Moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the Moon's poles. They still weren't certain, so they kept digging and, after a while, found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the Moon today, which means water probably was present on the Moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our Moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the Moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the Moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the Moon had a chaotic history back at the time when it was forming. as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too?
Hey, does anyone remember the gold rush? Back in the 19th century, prospectors were flooding California rivers with a pan in hand, chasing wealth. Well, scientists now say it might be time for the moon rush. Because apparently, precious metals worth over $1 trillion could be hiding underneath the surface of the moon. That's a lot of money. However, can we really reach it? And if so, who does it belong to? If you have ever paid close attention to the pictures of the moon, you probably noticed a lot of holes and craters. Our satellite is like a giant Swiss cheese. It has over 1.3 million craters, if you count those larger than 0.6 miles. But today, we're focusing on about 6,500 really big ones, those over 12 miles wide. Those were not made by little green men or little green moles, but rather by asteroids crashing into the moon since eternity. Scientists compared moon scans to meteorites, and after crunching the numbers, they think there could be a fortune in platinum hiding in those craters. What's exciting is that many of these resources could be just a few feet beneath the surface. The moon doesn't have an atmosphere like Earth, so there's no wind, rain, or earthquakes messing things up. That means those asteroid crashes left their priceless metals pretty much right where they landed, undisturbed in lunar dust for millions of years. With each crater like a giant space bowl catching platinum, iridium, palladium, and other metals. On Earth, we have to drill super deep just to get a tiny bit of these. By the way, did you know that most of the mineable gold on Earth likely came from ancient meteorites? When Earth first formed, almost all the original gold sank into the core. The stuff we can actually dig up today is probably what's left when space rocks slammed into the crust billions of years ago. So maybe you wonder why not reach for the asteroids and mine there? Well, that's because they're out of reach. Yes, in theory, it would be possible to mine from asteroids, but obviously the moon is way closer and easier to get to than any other giant rocks floating in space. We've already walked on it and brought back pieces of it to Earth, so it's fair to say we are familiar with it. This makes mining it a much smarter step than chasing unpredictable asteroids. However, asteroids are next on the list. Also, when it comes to mining the moon, it's not just about the prize. Some of those craters have frozen water. We know that because several missions, like NASA's Lunar Reconnaissance Orbiter and India's Chandrayaan-1, have found frozen water ice in dark craters near the moon's poles. This ice is super valuable because it can be broken down into oxygen and hydrogen. They are the parts needed to make rocket fuel. It could also be purified for astronauts to drink, or even used to help grow plants. Imagine filling up spaceships with fuel right on the moon before flying off to other planets. Not only does that sound pretty cool, but it's also economical and convenient. That would save us a ton of money and effort. And if we're already stopping to refuel, why not stick around and set up shop? It's about building a whole new space base and turning the moon into a launching pad for exploring deeper space. A moon base would let scientists study wild space weather, practice building habitats, and test robots in real lunar dust. I can't be the only one excited for the future where robots stream their live missions from the moon. The skills and knowledge we develop there could be essential for living on Mars or exploring the moons of Jupiter and beyond. This is not as far-fetched as you might believe. Companies like Astroforge and Carmen Plus are working on tech to mine asteroids, and maybe the moon someday. NASA's Artemis program is trying hard to set up a sustainable human presence on the moon in the next decade. And Europe's space agency is also eyeing lunar resources. So yeah, the idea of people and robots working together on the moon is probably just a matter of time. Still, it's not as simple as it sounds. There are big questions that humanity faces. Just like with the original gold rush, it's a bit of the Wild West when it comes to rules. The Outer Space Treaty, signed in 1967, says no country can claim the moon as its territory. However, it's pretty vague when it comes to private companies mining resources. So, if you build your rocket and mine some platinum first, is it yours? Well, as for right now, it's a guessing game. Countries are debating and trying to figure it out before the space gold rush turns into a lunar free-for-all battle royale. Then, there's the challenge of protecting the moon's one-of-a-kind environment. Some craters are so quiet that scientists dream of turning them into giant space observatories that study the universe without any radio noise from Earth. Mining nearby could shake things up or kick dust into the air. Lunar soil could damage the sensitive gadgets and ruin the billion-dollar science experiments. That would definitely annoy researchers. Plus, some parts of the moon have been untouched, and mining could wipe out cool spots we haven't even fully explored yet. So basically, we want to make sure we don't turn the moon into a lunar construction site before we've learned all its secrets. That's why some experts suggest setting up protected zones on the moon, like national parks here on Earth, where mining and heavy machines just aren't allowed. That way, we get the benefits of lunar resources but keep the moon's most important areas safe for research and discovery. But here's an even bigger question. How is this thing going to affect us casual Earthlings who can't take a walk up to the moon with our metal detectors and explore? The moon's rare metals aren't just worth a lot. They could actually be super useful for future tech. Platinum group metals, which might be found in lunar soil, are used in things like medical gear, satellites, and even some types of batteries and fuel cells. If the moon really is sitting on $1 trillion treasure, it could boost tech industries and possibly lower costs. There's also helium-3, a rare isotope found on the lunar surface. Scientists think it could someday be used for nuclear fusion, providing a clean, powerful source of energy that doesn't create greenhouse gases or long-term radioactive waste. If fusion becomes possible, even small amounts of helium-3 could power entire cities. One cool perk of using resources from space is that we could cut down on all the digging and pollution here on Earth. That means less damage to our environment and more sustainable ways to keep up with our growing population's needs. On the other hand, all these new opportunities could create new challenges. Of course, there's going to be a cosmic tug-of-war with who gets the goodies. Nobody wants the fear of missing out on a moon rush. Bottom line, lunar mining isn't just a science experiment. It's something that could affect economies, technology, and the environment here on Earth, for better or worse. When I was a kid, hundreds of years ago, we had the moon bases on the covers of our science books. One of the reasons why moon landing projects became so rare is that it just wasn't financially viable. Why should a country spend resources to get to the moon if there's nothing valuable up there? However, now that we think there's something out there, everything could change. That's why I already imagine myself working 9 to 5 on the moon, fixing robots and growing moon plants. But it's time to get back to Earth, so to speak. Nobody's setting up a moon McDonald's or booking lunar Airbnbs just yet. Even the most optimistic experts say we're still decades away from big mining operations or permanent lunar bases. For now, most missions will be robotic, experimental, and with price tags that will make your head hurt. So until we all get our moon mining helmets, it's something to think about while moon gazing. What about that wealth hiding on the bright side of the moon? Thank you for watching.